Sample 22, in the figure shown, both nozzles discharge water horizontally into the atmosphere at 10 meters per second. Find theta so that the resultant force on the unit is along the axis of the 200 mm diameter pipe. So this is the given figure. Summation forces y equals q rho quantity v2y minus v1y. So we have to consider the upper and the lower part. For the upper part, let's mark it 2 and lower part 3. So q rho of upper part is pi 0.05 squared times velocity 10 times 1000 kg per cubic meter, 25 pi kg per second. For the lower part, pi 0.075 radius times 10 meters per second times 1000. So it is 56.25 pi kg per second. So let's call this ry2, and on the lower part ry3. Let's assume ry2 is upward, ry3 is downward. The net resultant should be horizontal. That will hold the double nozzle in place. So the resultant force ry2 should be opposite, ry3 should be opposite to these cases. So that net ry would be 0 because the resultant is along the 200 mm diameter, on the axis of the 200 mm diameter nozzle or pipe. So ry2 equals, so there's no other force, ry2, because these are nozzles exposed to the atmosphere, so there's no pressure here, as well as at 3. So q rho of 2 times v2y, which is 10 meters per second sine of theta, then minus v1y, which is 0. So it is equal to 250 pi sine of theta upward. Then for the lower part, negative ry3 equals 56.25 q rho of 3 times, since the velocity here is 10 meters per second downward, it is negative. The y component is negative 10 sine of 10. Then v1y is 0 again. So ry3 is positive. Therefore, the direction of ry3 downward is correct. 97.68 pi downward. So ry equals 0, and it is equal to 250 pi ry2 minus ry3. So 250 pi sine theta minus 97.68 pi equals 0. Cancelling out, pi sine theta is 97.68 over 250. So from there we can solve theta. Inverse sine of 97.68 over 250, 23 degrees.